Honorable dignitaries, Chairman Dr. Balashankari Palghat Krishnan Ma'am, CEO, Renewable Kogan Globe, EECC, Co-Chairman Dr. A. Raviraj, Dean, Agricultural Engineering, members of Evaluation Committee, Dr. S. Karthikeyan Sir, Professor and Head, CPHT, Dr. M. Balakrishnan Sir, Professor and Head, FPE, Dr. R. Kavita Ma'am, Professor and Head, FMPE, faculty and student rapporteurs, professors, student committee members, and dear participants. A happy afternoon to one and all present here. I, Shiprali Panda, feel privileged to welcome you all on 2 days of 8th Agricultural Graduate Student Conference AGSC 2023 Globalization of Agriculture, Food, Fuel, Feed. Well, Albert Einstein said, if we knew what we were doing, it would not be called research, would it? So it is on this occasion like this, we get opportunities to test our skills, knowledge, and understanding. We look forward to get an exposure about what the best of the brains think about this dynamic theme on innovations in bioengineering and value addition. With this, we start our oral presentation session. Now, I would like to invite Dr. A. Ramalakshmi Ma'am, Rapporteur Faculty, to deliver welcome address for this session. Please, ma'am.
Good afternoon to all. So on behalf of SPGS, TNA Coimbatore, AGSC, it is my great pleasure to welcome you all to this 8th AGSC Conference 2023 on the globalization of agriculture under the theme Innovation in Bioengineering and Value Addition. So I am very much happy to welcome Chairman of this session, Dr. Balasankari, Madam, CEO of EECC. Welcome, Madam. Our beloved Dean AC and RI TNA Coimbatore, Dr. Raviraj sir, will be the co-chairman for this session. I welcome you, sir. Respected members of the committee, Dr. S. Karthikeyan sir, Professor at Center for Post-Service Technology, Dr. M. Balakrishnan, Professor at Food Process Engineering, and Dr. R. Kavita, Madam Farm Missionary. I welcome you all for this session. I also welcome senior professors, associate professor, assistant professors of different various departments. And I also welcome student representatives, I Prasant, and also I welcome all the presenters of this session. Thank you.
Thank you, ma'am. Next, I would like to invite the dynamic leader of our college, our beloved Dean, Dr. A. Raviraj sir, to deliver presidential address for this session.
So good afternoon to all of you. Already we are running late of time, so I'll be very short. So it's the 8th Agriculture Graduate Students Conference is being held here, and the session is Innovations in Bioengineering and Value Addition. And the right chief guest has arrived. She has global experience and knowledge as well. So she readily agreed to be present here on this occasion to deliver the lead talk. Thank you so much, ma'am, for accepting and giving the invited talk. And I'm sure that you will be getting benefited. Both the faculty members and students will be really benefited through your lecture. So it is not, she is connected with this college for this session alone. She's already giving a lot of capacity building, training and demonstration to the students. And I'm sure that we can take the profession to the next level and it will reach the global level. So the topic for this conference is globalization of agriculture. Morning we had one very good chief guest address by Dr. Rahavan. He is also associated with our college, and I'm happy to be here in this occasion and looking forward to listen to the invited talk and other student presentations as well. Thank you so much.
Thank you, sir, for your thoughtful words. It will be a privilege for me to welcome the chairperson of this session, Dr. Balashankari Palghat Krishnan ma'am, to address the participants with few valuable words and present the guest lecture. Coming to the achievements of this speaker, she has completed her Doctor of Philosophy in 2003 from Tamil Nadu Agricultural University and was a merit scholarship holder. She has completed her Master of Engineering from Asian Institute of Technology in 1997 and has been awarded 2 gold medals for her outstanding performance and has been awarded scholarship. And she has completed her Bachelor of Engineering from Tamil Nadu Agricultural University in 1994, a merit scholarship holder and recipient of gold medal for outstanding performance. Please, ma'am.
Good afternoon, everyone. And I'm very happy to be here on this occasion because this is my alma mater. And I just reflect when I see all the youngsters, I reflect myself. And it's a very nice occasion to interact with everyone and share my experience and views. So, very warm welcome. And thanks for the opportunity to Dean and all the professors and all my student colleagues. And today we are just, I'm not going to do anything because it's afternoon session. I know like it's a very tough time for all the students after lunch and it's been a long time. And on a lighter note, I'll just share some of the international experience and also some thoughts. Probably it could help you with your R&D in future, probably. So just to give some introduction about what we are doing, maybe the next slide. Actually, we have a company called Renewable Cogen Globe. EECC means Energy, Environment and Climate Change, and we are fully committed to reduce global carbon footprint. So that's we do everything under the roof of the sky, like whatever reduces the carbon footprint and makes this world a better place to live in. So that's our motto. And our company as such have more than 600 clients all over the world. And we have conducted more than 275 trainings, workshops, capacity building, some brainstorming sessions for all levels of stakeholders, right from the ministry until the grassroots level of the working people, wherever. And we have done more than 250 international projects worldwide and 100 climate change projects alone, more than 100 projects, especially the country development projects, which deals with different development activities in the country. And then more than 70 countries we have worked so far. And we have developed 30 national level country development programs. So this is in short. And this is our footprint, wherever we have done our projects. And next. And these are like some of our clients, ADB, World Bank, UN organizations, USAID, and some of these people are our clients in conducting the projects. Our field of expertise is in renewable energy, environment, climate change. Then project development, we do country program design, energy, whatever comes into the energy efficiency, carbon footprinting, and sustainability reporting. Then MSW management, IT solutions, training, capacity buildings, and whatever comes to go to sustainable development goals. So that's the ultimate thing. So today we'll just have a glimpse of how renewable energy can help into the sustainable development. So to have that, we'll just try to understand what sustainable development in agriculture can be. The famous quoting by the UN president is moving. We talk a lot about the global warming, right? So moving from the era of global warming to global boiling. That's a very alarming statement by the UN president, right? So it's time all of us think and act in a way the world is suitable for the next generations to live in. The major problem what we have as such is the emissions. You must all have been hearing about it, the global warming, the CO2 emissions and things like that. So that is one of the major problem. And then because of that, we enter into the global warming. We talk a lot, like we say like 2 degree, exceeding the 2 degrees higher than what it is now is going to be dangerous, and we are going to reach it much faster than anticipated because of our own anthropogenic activities. Nobody else is responsible. We are all responsible for what it is. And then a lot of talks about climate change, where even all the glaciers go down into water and things. So these are all, you might be knowing it. And to combat all these things, all the nations in the world, at least most of the nations in the world, have come together, and they are having a cordial relationship, because when we want to do something, it's not the individual person or individual thing. So it's every country has to take responsibility for that. So there was one Kyoto Protocol developed had in 1997, where all the countries together discussed about the global warming, and they came up with some rules and regulations, some approaches in reducing the global emissions. Then after that, there were a lot of carbon crediting things, and markets were all going on. And in 2016, that is another major milestone, where there was an agreement in Paris, and more than 216 countries participated, and at least 181 countries came together. And everybody said, because until then it was like the developed countries will pay for reducing the carbon emissions in the developing countries, right? So what will the developing countries do? But they should feel they cannot always wait for some money from somebody and do nothing. So they have to do something. So everybody has to be committed to do something. So that is what happened in Paris Agreement, where at least 181 countries came forward and gave their NDC, that's called nationally determined contributions, where they said every country gave a strategy saying like this is where we are in emission, in the global emission, and we will reduce to this level by ourselves, this much. And if there is an external funding, then another percentage. So that is how every country has committed, because everyone wants to reduce or do not want the temperature to go above 2 degrees before 2050. So that is the agreement. So with all these things, and also UN came up with the Sustainable Development Goals. We have the 17 goals. So all these are put together, and that is where all our projects are marching towards. Anybody is having any question, anytime free to ask. So no problem. And then regarding the sustainable agriculture, the statistics say why agriculture plays a major role in this kind of global emission or sustainability kind of thing is like the energy consumption in agriculture for food production is around 30%. So wherever there is energy, then there will be emission. Meaning, because energy generally we go for the fossil fuel consumption, which means it will lead to the emissions. And then also, it says that 31% of emissions, of the global emissions, occur from the agricultural activities because of various things like burning and sometimes using the fertilizers, chemical fertilizers, and things like that. So it's our responsibility to reduce all these and move towards a sustainable business in agriculture. So this is another statistics just showing that the global emissions are 51 million tons of carbon dioxide equivalent. The E symbolizes, like there are other gases too, like methane and everything, but they are all converted equivalent to carbon dioxide. That's why they always use the word equivalent, E. And out of that, 5.79 million tons are from agricultural activities, and then 1.64 billion tons are from the land use and forestry. So that graph just shows like how the activities in the agricultural livestock keeps increasing the emission. The yellow one is the crops and livestock, and the land use pattern change. So you can see that ultimately there is an increase over the years. And in the last, I think, 10 years, there is a 20% increase, which was alarming. So that's why everyone talks about sustainability in agriculture now. Yeah, next one. And this is just to have like in Asian countries, like some of the countries, and Asia seems to be the highest level of emitter in the world. So that is why we really need to be careful. No, that is no. It will be usually it is indirectly, but it'll be under the adaptation kind of thing. There are two things. I'll let you know. There is one thing called mitigation. There is another thing called adaptation. So usually the crops and livestock comes under this, and agricultural land use is like where we go for a larger kind of a plantation, or it's a larger area, not typically an agriculture activity. So that's separate one. So this shows like Asia is the biggest emitter, like contributor for crops and livestock. And livestock majorly it contributes. Oh, okay. Okay. And next slide, please. And you know the activities, like from the source of emission, like you know the activities in general. Even when normally a plant is breathing, we know like carbon dioxide is emitted. So does it mean it's emission? Not at all, because it's in general, without the human activity, when this happens, it is always balanced. The amount of carbon dioxide emitted, it's always taken by the plant itself. So absolutely there is a balance is maintained. What happens is when we lay our hands on these, then we create always the problem. We are so greedy, like we always create a problem. So that is where we use a lot of chemicals. We use like we really wanted to get more than what somebody can produce or some land can produce. So we try to exploit everything, and that is where the emission kind of things happens. So there are like a lot of not see when I say CO2, as I said earlier, it's not only the carbon dioxide. When I put equivalent, that E sign, it means I include there are other gases, like there are many gases, many gases. Basically, at least 6 type of gases which are predominant, like methane and N2O and things like that. So those will be accounted. So these are the gases you can see, like say enteric fermentation of from the livestock. Livestock is one of the major contributor, and some source from the manure and other activities of agriculture. Next slide, please. Okay, this is just a gist of what will happen here. Like whenever there is a pointer or something. The water demands is like always like evapotranspiration, soil salinity. All these happens, which results in water demand increase. Everybody says the next the world war can happen because of the water. So the whole all the countries can fight because of that. And then whenever there is a change in the hello, can you hear me?
Hello.
So the time of occurrence, the type, the volume, everything causes a change. And similarly, whenever when you think of the crop yield decreases. Unsuitable crops we have because it may not be suitable for our life or even the animals. Pest and crop disease, all these things result in crop price increase. And all these things put together result in food security shortage, which we are really facing. We can see in some of the countries, some of the places, even in our own country, in many places. So now, how to combat all these things in a sustainable way? So we are trying to pull the important objectives from the Sustainable Development Goals. I was saying there are 17 goals proposed by SDG. That's the UN organization has proposed. So from that, so this is where we are pulling in different activities where you take care of two things. One, the mitigation and the adaptation. So mitigation is something which you are going to reduce the emission from where it is, right? So until you reduce, then how are you going to live? So that is called adaptation. You should also try to know to live in the existing situation in a better way without causing much more damage. So that is called adaptation. So there are always two things, mitigation and the adaptation. So there are different activities like the forestry management, food management, everything comes into the picture. So energy efficiency activities, generation from renewables, everything comes into the picture. Next slide. Okay, so some of the measures to mitigate, I'm talking about the mitigation, the first part, climate change in the agricultural sector. This is the potential we have from now, where we are now, because I say about 2030, the Paris alignment has agreed to reduce 2% by 2030. Most of the countries have given the commitment. So we say like a lot of activities like cropland management, grazing, restore cultivation, so many all activities related to water management, everything. So from here, this says this is the amount of carbon dioxide emissions we can reduce, because this is the amount which is happening because of proper activities. We can reduce CO2. The red color ones are CO2, and the blue ones are L2O, and the yellow ones are the methane. You can see that especially the rice management and the livestock management, they yield more of methane emission. And why methane is, though it is small, why methane has to be like, you have to get alarmed, because it is 28 times equivalent to the emission of carbon dioxide. So meaning even a small amount of methane is 28 times dangerous than CO2. So I wouldn't say they are all dangerous. As I said, when we put our hands in that, apart from the normal things, then definitely there is going to be, whenever we try, it is like a butterfly effect. Whenever we try to put our hand on one side, there will be some problem on the other side. When it is naturally happening, things always, nature always has a way to sort out the things. Okay. So for the renewable energies, all of you must be aware, like one is the biomass energy we have, right from all the agricultural residues and everything. And then the solar energy, then wind energy, the hydropower energy, and also the geothermal energy. So all of these, all of you are aware. And for the biomass sources, we have being in the relevant field, we have like industrial resources, animal residues, municipal solid waste, sewage treatment kind of things, and then agricultural crop residues, forestry crops and resources. And now we are also coming up with the agro-photovoltaics, where you can see like the systems are like this, and you can also have the crops along with them, because solar will always occupy a lot of space. Okay. So when we talk about the resources, like the agricultural resources, we always talk about the biofuels. They are the ones, because we are trying to avoid the fossil fuels like the petrol or diesel, right? So for this, we have the fuels from the agricultural resources in three forms, like the solids, the liquids, and the gases. The solids, most of the agricultural residues, say the wood waste, the rice husk, and maybe even the palm waste, everything, we can use them as the solid waste. It's nothing but like what we have been doing for years. Even our forefathers were using them for cooking and things like that. The same principle, but now in a way like we have to do scientifically for catering to our different needs. And then bioethanol, like liquid waste, all of you were aware. Bioethanol, biodiesel, from various sources like the cassava processing industries, where you can produce ethanol from the water, and the sugarcane molasses, you can produce ethanol and things like that. And even from the palm waste, so you can produce ethanol. And then also the gaseous form, the biogas. Like all of us are very aware of the powder, and also from a lot of industries like starch industries, palm oil industries, even the avocado fields. Some of the industries we have gone through even for rose leaves. So anything and everything, wherever you have the bio, you can go for the biogas. These are some. Okay. I said these are the applications. Right, the palm power, green electricity generation, all these things, transport, rural electrification, and heat generation. So these are the process for which you can use all of these materials. These are some of the fuels, solid biofuels. You know what is this? Paddy straw. You can see these are the people. So that is like they have put like a hill, like it is in Africa, Nigeria, where they have more than 1,000 old type of colors, and they just throw the rice husk. So only there in Africa. Africa is different, and Thailand. I still remember when the fuel was free. Everybody used to throw rice husk. Now no more. It's expensive than any other fuel. So the cost of rices per ton is really very high, more than 3,000 maybe INR per tons or something like that. So it's expensive. And these are palm based, the palm shell, coconut based. This is tapioca rhizome, and wood based. So all these are there. So sometimes they are bay, and this is sugarcane based, everything. And bagas. Yes, yeah. Yeah, sometimes wood industries you have, and from all these to densify them, you use the balers for the straw and also some pellets. So you can make the pellets out of these kind of waste to use as the fuel. It's like so. This is what interesting project, like just to make you okay. And this is a project of around 5 megawatt with rice husk in Africa, Nigeria. And you can see there are thousands of old hullas, like Engelberg hullas, like they call it, a very old one, where you get even the rice and the rices together. And then they are the women who take the rice husk from the mills and they just dump it somewhere high. You can see how tall it is. Like so you can see it's taller than a human being. And they don't do anything. It's just wasted and it's burnt. And then the government came up with one idea where they can put up one power plant. And this is one example for that. And it really helped them. It is all the diesel-based hullers, So they generate electricity from these rice husks, and they can use it for the same the hullers instead of diesel. So that was the idea. The next one. And sometimes there are a lot of activities where the burning of the wood waste or even the agriculture produces are avoided by a lot of governments, and they just wanted to improve the lifestyle or the cropping pattern or cropping styles. So this is one such example in Madagascar where they try to avoid the slash burning. And this is one interesting project in Wood SEZ in Gabon. Gabon is one of the negative emitter. There are only few negative emitters. One is Bhutan and another one is Gabon. And Gabon has 80% of forest area. It's a very beautiful place, a small one, which a French colony, and somewhere near the Botswana and that area. So very nice one. And what they did is the government developed a wood special economic zone, because a lot of wood, 80% forest, so their main income source is wood. So they tried to develop a lot of special economic zone with a lot of works, the plywoods, whatever type of wood, the pressed wood or some kind of dolls, whatever furniture, everything, and all the waste, the wood waste. So what they would do, right, after all the activities. So the government planned for using those wood to generate electricity and also the steam. Steam can be used for processing, say in the plywood industries and something like that, and electricity for lighting and operation purposes within the special economic zone. So this is one such activity. Otherwise, if not used properly, all these wood wastes and everything will be burnt. So they are trying to use in a better way. And another one. This is also a very interesting project from Singapore, where you can never think of so much of biomass. what Singapore did is, but they are very diligent country. And what they did is, they had the avenue trees, right? The tree twigs everywhere. So they have to cut them in a regular interval to maintain the beauty of the roads and everything. And with the tree twigs being cut, those are used in a small power plant, say 2 megawatt power plant. That's a real nice thing they did. And this is the one. So like that. And yeah, this is a wood-based power plant in Thailand. And can you imagine that's a power plant on this figure? Never looks like a very modern building. So that's how the Thai people do. They really always like to have the looks should be very nice everywhere, including the power plants. So this is a wood-based power plant. And this is like when we saw telling about the fuel, right? One is for the power generation. Then we have the cooking things, because when we go to Africa, even in India and the rural areas, Bangladesh or a lot of Asian countries, still people rely on the wood, maybe taken from the forest, illegal cutting of trees and something like that. So to avoid that, like different countries are coming up with different programs, and just to, you make efficient use of the available wood resource or whatever, maybe the pellets in the form of pellets or whatever. They are coming up with a lot of cook stove. So even in our university, it is there, a lot of things you all must be aware. But it's a very, very important program worldwide, especially in African and Asian countries. And this is another example of 42 megawatt sugar power plant, sugarcane power plant. The bagasse is used, and usually you can see how conveying system, and it's a very big one. It was one of the first sugar plant in Thailand that time, and with high technology, 65 bar and things like that. This is also another rice husk power plant. Next one. Yeah. This is one of the rice husk power plant where rice husk ash has an export value. The quality of the rice husk, if it is maintained at a proper prescribed standard level, it can be exported, and it has very high value apart from generation of electricity. So that is one thing, you can export it for various purposes. For the liquid waste, like, like to produce ethanol, one of the sources is the palm oil, and various other things are there. Starch is there, cellulose, everything. The next one. This is a gasification plant from the wood waste. And for the gasification, from my experience, like when I talk to them, I think it's a successful technology, right? Lot of gasification plants were installed in like Cambodia, Laos, all are Indian technology. India is one of the pioneers in the gasifiers. But to the R&D, since it's R&D, from our experience, I just have one request. Gasifier as such, when it comes for the thermal, perfect. Absolutely no problem. Any fuel you put it, it'll give you, it can burn and it can give you enough heat, whatever. Heat generation, perfect, absolutely no problem. But when it is electricity generation, you really have a problem, because you have the tar formation, and it looks to be the simplest of the technologies with not much moving components. But if I have a request to like very high institution like TNAU, if something can be done on how to overcome the impacts of tar, and then smooth electricity generation is possible, then I think there's nothing else other than that. So that will be the requirement of the hour actually. So if something can be done on that, would be really useful in a commercial way. There are plans especially wood it works well. Rice is still problem. IAC technology, so many are there. GPI is there. So many are there, but still there is some problem because of its corrosion and sulfur and things like that. But as I said, any gasifier on a commercial scale for thermal, perfect, no issues at all. But when it comes to the electricity part, then the tar formation makes it difficult to like prolong over years. So most of the places it just stops operating and it goes as a waste. The investment goes as a waste. So if something can be done, this is my request. If something can be done in TNAU, I think there's nothing like it on that aspect. And then we have the biogas. So the biogas is one of the project which we are doing in Bangladesh right now. It's going on where the entire value chain of livestock and dairy development is happening. And they are trying to install 3 to 20 tons per day of biogas. And then also wherever renewables are possible, for example, the milk chillers, right? Wherever the village milk collection centers will be there, cooperative centers will be there, and they wanted to store the milk. So they can try to go for solar based chillers. So these are the kind of things which are being used, trying to be used in Bangladesh, like also the solar pumping for fodder cultivation. So this is where such applications are possible. Next one. You can see this is one of the chicken farm with 50,000 chicken and their biogas plant, and that's the cow manger and things like that. This one is the biogas bottle. Then you have like enough quantity of biogas generated. That's the latest technology. The trend is picking up even in India now. We have better than in Bangladesh, definitely. And where you can try to use it instead of LPG. When you make it, purify it and compress it, or CNG, instead of a CNG, I would say as a CNG. So you can use it like that. This is where the biogas cooking used in houses. And this is an abortire, where like abortire is very popular. Like in African countries, they don't eat a food without meat. Even in Middle East, or if you go to Bangladesh or some kind of countries, they don't eat a meal without meat. So meat and meat products are very important. So they have a systematic abortires. And then this is one where we try to collect, because if the wastes are not treated, then they are really going to be more detrimental than a dairy waste or something, because they are all bio waste, like the living flesh and everything will be there. So we try to make a biogas digester for them, and where you get all the animal wash and everything will be collected, and you get a digester for that. It's a government project in Kenya. So that was one thing. That's another where we can apply the biogas technologies. And this is the one which was, I was saying about the avocado processing center. The waste from these, after removing the pulp and everything, so the waste, they tried to take it to a biogas digester. So that was done. And the orange one is in a cut flower export center, where the rose leaves, because only the flowers will be exported, what will happen to the leaves, right? So they cut all the leaves, the falling ones and whatever, and they use it for biogas generation. So they can decay. So meaning you should have an appropriate environment for that, and generate biogas from the rose leaves. So that is another thing. Then this is one of the commercial aspects of starch industries. Thailand is one of it's called the world's cuisine, like where they export a lot of starch. And we ourselves have done more than 40 biogas plants project in starch industries. So they have a lot of starch industries. And that is a biogas digester. You can see that it's a concrete structure. And the gas generated is used in the boiler for heating. And instead of the LPG they were using earlier, they use the biogas for that. So you can see the bags of starch being kept for export. There, the last picture is that. So, and this is the open anaerobic tank where they collect all the waste. Instead of that, it will go to the digesters, concrete digesters. Next one. There are different other forms, like you can see a balloon type of digester, like the gas holder. This is also a metallic gas holder, and this is a gas engine where they connect it to for generating electricity. And this is the ethanol-based cooking, and this is the biogas-based cooking which they use in Africa. So that's one thing. Safi is one of the popular brand for ethanol. Used to be, not now, used to be, maybe some 3-4 years back. Yeah. And these are all the agriculture base. So we still have the other renewables, the solar, the wind, and the hydro, where we can use it for agricultural purposes. So solar, we already know, like for pumping, drying, chilling, and lighting the farm. And wind, also like almost the same applications like solar. So we get the electricity and use it for whatever purposes. And in the hydro, we know the bigger hydro where we get water for irrigation. And there are also the small ones and also the pico hydros where you can generate electricity less than a kilowatt in the irrigation channel, the small channels which you can use it. And the micro ones are maybe few kilowatts you can generate from your waterways or irrigation channel, bigger irrigation channels. So this is where we can still use it for agricultural purpose. Next one. So these are some of the solar applications like pumping, drying, street lighting, and things like that. Next one. What is this? Tungringlan Papu. Can you identify anything interesting in this? Solar panel. This is a solar home system project where in Bangladesh. It's one of the largest or biggest solar home system installation, 5 million solar home system installation. This is nothing, I won't say it is nothing related to agriculture, but just to make you not to sleep and just enjoy what it is. So on a lighter note. So see how they have mounted. The government gave a lot of donors and the government, and they have a quasi-government organization which implemented all these. And one of the houses, maybe I think it's a 10-watt peak system, and they didn't have a place even in it. It's all installed in the off-grid areas where there is no electricity at all. And the change that it made in the life of the people is something amazing. Amazing means amazing. And you won't even know the reasons, like so many reasons which made the lives of the people better. And this is they don't even have a house or proper roof to install that. So they put in a nearby tree on the top of the tree. And the original was, so they just wanted to replace this, the solar. It made a lot of difference in their life. You can see I said it's an off-grid area, meaning completely no electricity, zero electricity, just darkness after maybe 7 or 8, something like that. Nobody can even walk in the streets. And the women had difficulty in walking on the road. And then once this came, you can see that they are able to study, even in the nights. Maybe from a tuition center, they are able to walk on the roads safely. It's almost 8 p.m. in the night, which they could never imagine before this came, the solar home system came. So this made, I wouldn't say this directly had an impact on agriculture, but definitely it had an impact on the efficiency, the work, whatever they wanted to do, the people could do, even after when it was dark, better education. You won't believe even better fertilization among the women because the health was improved. So many things happened. So the result of this particular project was really amazing. Yeah. This is just on a lighter note. to see if you are all sleeping or not. And next one. And every project we always, not only that, every project we talk of the women development. There's no project without women and children's welfare. There is nothing without that. So it's all integral part of it. You can see even for the solar home systems, women are becoming entrepreneurs. Like they can make the components, fix the components and everything, and they can. A lot of women entrepreneurs have been there. And then next one. Any idea what it is? Imagination, wild imagination. That's Kilimanjaro. Top view of Kilimanjaro. Okay. What we see in the picture, like Kilimanjaro, பாட்டு வரும்ல. That's not Kilimanjaro. That is Machu Picchu. Peru. That's not Kilimanjaro. This is the real Kilimanjaro. And this is in Tanzania. It's a small island called Chole Island. இது ஏதாவது ஐடியா இருக்கா? ஏதாவது கெஸ் பண்ண முடியுதா என்னன்னு? Situation of the people in that island. It's a small island. Electricity grid கிடையாது. So it's இதுதான் அதோட ஹாஸ்பிட்டல். இருக்கிற ஒரே ஒரு ஹாஸ்பிட்டல். அண்ட் கிரிட் எலக்ட்ரிசிட்டி இல்லாதனால இட்ஸ் கம்ப்ளீட்டா சோலார், ஒரே ஒரு சோலார் ஒரு ஒரு பவர் பிளான்ட் இருக்கு, 1 மெகாவாட் ஃபுல் ஐலாண்டை டேக் கேர் பண்ணிக்க. இல்ல சாரி, இந்த பர்டிகுலர் டேக் கேர் பண்ணிக்க இதுக்கு ஒரு சோலார் ஒன்று தனியா இருக்கு, சோலார் பேனல் இருக்கு. இது ஒரு ஹாஸ்பிட்டல். ஜஸ்ட் இமேஜின் ஹவு பீப்புள் ஆர் லிவிங், ரைட்? And the solar has definitely made a lot of changes in the renewable energy, and especially when we talk about solar, it definitely has made a lot of changes in a lot of lives. இது என்ன தெரிஞ்சுதா? Exactly. It's an ambulance, especially free for delivery. It's a tricycle. And இதுதான் அங்க இருக்கு, அந்த ஹோல் ஐலாண்ட்லயே இதுதான் இருக்கு. So like it's a long way. Solar has given them some light of hope and long way. இந்த ஐலாண்ட் போயிட்டு வந்து தான் நான் நெக்ஸ்ட் இங்க வந்த உடனே பேராடெங்கு வந்து படுத்துனேன், உட முடியாமாச்சு. இஃப் ஐ ஹேட் பீன் தேர், அங்கதான் நான் இருந்திருக்கணும். So just on a lighter note, but you can see the impact what the renewables can create. When I say agriculture, definitely at the grassroots level, the rural people, definitely it means a lot. Next one. And this is the hydropower plant in Tanzania. You won't believe, 30 kilometers travel பண்றதுக்கு, 30 kilometers of road, trafficலாம் எதுவுமே இல்லை, travel பண்றதுக்கு it took 6 hours. நடந்து போயிருந்தா கூட போயிருப்போம் போல. 4 அடி ஏறினா 10 அடி சறுக்கும் இந்த மாதிரி. அங்க ரெயின் வந்தாலும் சுத்தமா ஏற முடியாது. So imagine how அங்க ஒரு ஹைட்ரோ பவர் பிளான்ட் இருக்கு, 1 மெகாவாட் ஹைட்ரோ பவர் பிளான்ட். அண்ட் வருஷத்துல 8 மாசம் மழை பெய்யும். They had such a difficulty in transporting one equipment கொண்டு வந்து கீழே வச்சுட்டாங்க. அந்த மலையில ஏறி எப்படி கொண்டு போய் போடுறதாங்க. So they really had lot of difficulties. அங்க no other electricity. இந்த 1 மெகாவாட் ஹைட்ரோ அங்க வந்து வந்ததுக்கு அப்புறம் தான் it's a missionary, like Christian missionaries, அவங்களுக்கு யூரோப்பியன் ஃபண்டிங் வரும். பட் only after that, அந்த பர்டிகுலர் அங்க ஸ்கூல் இருக்கு, இது அந்த ஸ்கூல் சில்ட்ரன் தான். அந்த ஸ்கூலுக்கான எலக்ட்ரிசிட்டி இஸ் ஒன்லி ஃப்ரம் தட். சாயந்தரம் 6 மணிக்கு மேல ஆனா 8 மணி வரலும் எலக்ட்ரிசிட்டி இருக்கும், அது வரலும் ஓடும். 8 மணிக்கு மேல நோ சிம் கார்டு, நோ இன்டர்நெட், நத்திங். உட்காந்து நம்ம அப்படியே வானத்தை பார்த்துட்டு இருக்கலாம், அப்சல்யூட்லி அப்படி இருக்கலாம். So how the renewables are making changes in life ன்றது இது. And இது வந்து another hydro plant, 7.8 megawatt, operated exclusively by women, especially the sisters. It's an amazing one, completely. So this so far we were discussing about mitigation. So எப்படி இது எல்லா ஆக்டிவிட்டிஸுமே பார்த்தீங்கன்னா renewables யூஸ் பண்ணியிருப்போம். We have avoided the use of diesel, some places the kerosene or petrol or whatever. So இது எல்லாமே mitigation. So meaning CO2 குறைச்சிருக்கும். இப்ப இருக்கிற லெவல்ல how do we get adjusted among ourselves? So that is called as adaptation. So இருக்கிறதுல எப்படியும் adjust பண்ணி பெட்டரா இருக்கணும். So this is one such system which was done in a Chad area in Africa. They tried to install solar powered agri-business centers, and using that they tried to make a change in the efficient irrigation systems, then some cultivation practices, the resources, and also the community. Whenever I say adaptation, there should be a community level development, lot of grassroots level development. So that happened here in Chad. And there is another one like where they try to do climate smart agricultural practices, especially Thailand, Cambodia, Lao, PDR, and remote places. So they try to train the farmers to how to adapt to the changing climate, which results in the because of the areas, especially Cambodia, Vietnam, Thailand. Some of the agricultural areas are very much sensitive to the climate change. So they have to make them understand and live accordingly. So adiketa mari adaptation practices were all considered here completely throughout the value chain, how to improve their degraded land and how to go for a better marketing, better cropping, better systems like that. And for all these, we really need capacity development at all levels, as necessary, right from the policy makers, the ministries, the donors, or the international people. Then comes the next level of the private sector things, then even at the workers, then at the grassroots level. So that is very, very important to educate them in different ways. So when we follow all these aspects on a nutshell, definitely for agriculture, we can come up with improved food production, environmental health, then minimization of off-site environmental impacts we can reduce, and risk factors, and we can you maximize or optimize the use of available resources, and also the cost we can reduce. So this is where the agriculture, sustainable agriculture is centered at. Thank you.
Thank you, ma'am. It's really insightful. The session is now open for discussion.
Yes. In Punjab, we did street lighting projects, and then also one transformer change, like the old transformers were removed and new transformers were because of the emissions from the transformers, especially the SF6 will be there. So that was changed, and the carbon credit was done by the state government of Punjab. Gasifiers. Yes. Please make it commercial. That's my request. Yeah. Yeah, just please make it commercial. That'd be really useful, because that's where the lacuna we see. We say gasification is easy, but it's not so. It's easy on paper, but when it comes for electricity generation, never. You can see everywhere in Africa, Cambodia, Laos, they all use we have the IISC technology, API, and I think GPI, right? GPI and everything. Then Ankur technologies, and so many are there. But even a lot of investments they have done. We are better. Like we and China are the pioneers in gasifiers. But when it comes to this point, they install, we have seen like abandoned after a 2-year or 3-year. Due to one main reason is this one, especially this one, and other thing is, of course, there are like training and other things. Like India, we always have a person. If one person is not there, there is somebody always at a lower caste who can always come and help us. Abroad, not possible. Definitely not possible. So the main failure has happened because of that. If we can do on that, we'll be the king. Yeah, yeah. Yeah, what happened in Tamil Nadu was like even EID Paris is there, Sri Ram is there, so many power plants are there. What happened here is like the government gave a subsidy, like if you replace the coal, all these power plants were using coal. So the government gave a subsidy, I think before 10 years, something like that. If you replace the coal with the biomass, then they would announce some 30-40% or something like that. So to get that, they all did. Whenever you talk about biomass, you really need to be careful. It's the most critical thing. You always should have an excess of biomass than what we are using. That's how everybody or every donor, everyone will approve a biogas thing. In fact, if you go to Europe, European government doesn't approve a biomass power plant project. They say no more a biomass project. It's all because they don't want to cut any trees, something like that. So every country has its own rule. And here that's what happened. So the government gave subsidy. To avail the subsidy and the special tariff for the biomass based electricity, people took up that. But finally, when we really visited there is no one to monitor because it's from the government. And when we went there, they were definitely using coal. They were definitely using coal because they didn't have enough supply of biomass, or they don't have their own biomass plantation. So we could see that. So that's a problem. When we say biomass, then you really need to be very careful. Anything? Am I late? Did they take more time?
Thank you, participants. Now we are going to start the
Thank you.
oral presentation.
Thanks.
The rules for the presentation are each participant will be given 7 minutes for their presentation and 3 minutes for discussion. So kindly please stick to the time and best of luck to all the participants. So we have our first participant S. Ratnavel, and he will be presenting on assessment of energy and water footprints in Pokali paddy cultivation.
Being one and all present here, myself Ratnavel S from Department of Pharmaceutical and Power Engineering, PhD scholar. Today I am going to present about my small research work that's on assessment of energy and water footprints in Pokali paddy cultivation, that is prevalent in Central Kerala. These are the pictures of Pokali paddy cultivation, and this Pokali paddy cultivation is a unique ecosystem under which several traditional paddy varieties are cultivated, and this includes shrimp cultivation and also paddy cultivation. Yearly once shrimp cultivation will be followed and paddy cultivation will be done. And this is mostly done in under saline water condition because of the area will be under lowland situation. This Pokali ecosystem is mostly prevalent in three main districts in Kerala, that is Thrissur, Ernakulam and Alappuzha. And here we have the data of normal rainfall of each district and share of Pokali paddy cultivation in each district. And Thrissur has the highest share of cultivation. And the major traditional varieties that are cultivated in this Pokali ecosystem are given. And there are also hybrid varieties developed in this Pokali ecosystem by RRS Vaitila by Kerala Agriculture University. And these hybrid varieties have the highest yield that's near to our normal paddy varieties, but these traditional varieties will be having lower yield. and the crop height will be up to 5 to 6 feet height, but the hybrid varieties are comparatively having lower height. And the total labor requirement for this cultivation of Pokali paddy will be around 150 to 200. Since this is in stagnated water condition, mechanization is very poor, and also there is no irrigation, no fertilizer, and no pesticide, no weedicides used in this cultivation. And the other two data are the consumable water per person for his daily day-to-day life is including all indirect consumption of water is 150 liters per person, and energy consumption per person was about 4,000 kilocalories per day. And these data were used for assessing the energy and water footprints. And this is the procedure followed for calculating the energy consumption for manual cultivation. And this is the procedure followed for calculating the energy consumption for a mechanical cultivational operations. Only harvesting and diking operations were slightly mechanized. Other operations have not been mechanized. So only the example of harvesting has been taken. The overall energy footprint for this Pokali paddy cultivation is 2.1 megajoule to 5.6 megajoule per kg of threshed paddy. This is comparatively lesser than other normal paddy varieties where we use our normal mechanization practices. And for manual harvesting, we have about 0.48 to 1.93 megajoules of energy consumption. But we have 1.5 to 15.42 megajoule of energy consumption in case of mechanical harvesting. And this is subjected to 25% efficiency of the machine. And in that energy consumption, direct energy consumption is 1.46 to 14.66, and indirect is 0.075 to 0.75 megajoules. With respect to field efficiency, when the field efficiency increases, the energy consumption gets reduces. Same case is with the field capacity, but the machines used in the Pokali fields have a lower field capacity and also lower field efficiency. The amount of energy consumed will be reduced. This is the amount of virtual water assessed in different districts based on the yield, based on the variety, whether it is a traditional variety or whether it is a hybrid variety. The yield will be varying, and based on this, the amount of virtual water has been estimated. And virtual water comparison with other crops and other varieties, the Pokali paddy has the least consumption of virtual water. This is because of here there is no irrigation and there is no fertilizer, pesticide or weedicide used, and some amount of backwaters has been involved in this cultivation that is not have been accounted. Only the precipitation have been accounted. Hence, the consumption of virtual water is lower for this case. And with this lower energy and water consumption, this variety of paddy can be cultivated in certain situations in India where there are flooding cases or saline land prevalent areas. And already in West Bengal and some parts of Odisha, they have got this variety and they are applying in their fields. And our Tamil Nadu Agricultural University has taken this variety for crossing over to produce new drought tolerant varieties. Thank you.
Thank you. The session is open for discussion.
Not good in this. What is virtual water?
Ma'am, the amount of water that is consumed by a product throughout its production process, from its seed to yield means up to its food grain part. So the total amount of water consumed direct and also indirect will be accounted in this virtual water. Yes, ma'am. Be comparing with ma'am, because it has no irrigation and also it has no fertilizer or pesticide or weedicide. You are not using anything, so indirect water consumption also less. Only precipitation will be utilized by this variety. So that's why it's yes, ma'am. It's traditional variety, but also hybrid varieties has also been released in this with this one. Sir, this nutritional value and taste and smell of this food prepared out of this variety will be good comparing with the other varieties, sir. And it is high in protein content comparing with the other varieties. Yes. Sir, that name is Pokkam means deep, sir. Ali means standing. That because of its height, that yes, sir, Malayalam varieties.
That water footprint is very low.
Yes, sir.
So since irrigation is not being given, we cannot say that one. Have you analyzed the rainfall pattern of that area? How much is the rainfall for that area? Have you worked out any water budgeting or something like that? Because you told backwater is also being used.
Yes, sir.
Since they're not irrigating, it doesn't mean that the crop is not requiring water, right?
Yes, sir.
It is given through rainfall or through backwaters.
From rainfall,
Have you worked out any water budgeting for this one?
sir, rainfall I have accounted, sir. Since it is a fresh water, I have accounted precipitation, sir. But backwater is not out of fresh water, so that one not accounted.
Unless we work out the water budgeting, we will not be able to say that this variety is having low water requirement or something. Do you have any review article for that? Do you have any review?
No, sir. I have reviewed some articles, research articles, sir. They have accounted irrigation with precipitation, sir. But in this case, no irrigation is not.
Okay, good.
Thank you, sir. Yes. Yes, sir. Yes, sir.
I think it is growth this season between August, September to.
Yes, sir. From July to November. Yes, sir. Yes, sir. Yes, sir.
What made it?
Sir, because if since it is a high rainfall area, comparing with the other regions, maybe this can be consuming more water in case of precipitation with respect to precipitation. So that's why there was some. Yes, sir.
That time
Yes, sir. Yes, sir.
incidentally the power energy input also will be. What made you take up this problem?
Sir, that maybe sometimes it may be that some other high rainfall regions may have similar kind of virtual content. I wanted to compare with other paddy varieties with this ones.
Any questions?
Thank you.
Thank you, Anand.
So next participant is B. Priyadarshini.
Good evening to everyone. I'm Priyadarshini, pursuing post-graduation in the Department of Farm Machinery and Power Engineering. And today I will be discussing about my undergraduate project on design and development of claw mechanism for punch planter. Before entering into the topic, let's discuss the reason behind my title. Actually, why punch planting? For more understanding, let's get into origin of tillage. When do we start practicing tillage operation? Do anyone? Actually, on the first century of BC, the tillage operations started. And you won't believe that only 200 years before the plow was invented, an iron plow was invented in China. So, no one can deny that tillage operation has its own pros and cons. But at the same time, I think we have to concern on the other side also. Like, we know that what tillage do. Actually, tillage fractures the soil, which leads to disturbance of a physical structure of the soil, which may leads to soil erosion. So, on that thought, went into the punch planting technique with zero tillage or with minimum tillage. With the help of this implement, we have only have a minimal disturbance of the physical structure of the soil. Next, the mechanism we used. You won't believe that we inspired from a mechanical tip pencil for this mechanism. Basically, a claw mechanism is a kind of fingers or a claws which used to grab or manipulate some kind of object. Next. Actually, this is the CAD diagram for our punch planter, which consists of two different units. One is punching unit, and another is a seed metering mechanism. Basically, the punching unit insert the seed into the soil instead of just sowing on the furrow. And we used cup feed mechanism for this. We designed this whole unit for mini tractor, because we know that mini tractor costs only around 3 to 4 lakhs, but a 40 HP tractor will be around costly, so it will be difficult for the farmer to afford. Next. And this is in this you can clearly see the how the claw mechanism works. Basically, we have designed the implement for 2-row planter for maize, with two punching units, which has 4 fingers. The claw mechanism is basically works on the regulation of the cam, which is connected to a shaft. Next. And this is how the field pattern will be. The plant spacing will be around 60 centimeter as it is designed for maize. Next. Next. And power transmission unit. While incorporating two different units in a same implement, it is very much important to synchronize the two different units. Like here we have punching unit also, at the same time seed metering unit also. We have to synchronize the function of these two with the help of this ground wheel. So the whole unit is now at the control of the ground wheel. Cup feed mechanism. Yeah, this is the seed metering mechanism we used. Why we went into this mechanism? Because the disc of the seed metering can be exchanged when we are trying to incorporate for some other crops. For that, we have manufactured in a way we can detach the disc and we can use it for some other crops. And on the result, we have got the observation of it went to the depth of 50 mm. Actually, we tried to go to the depth of 70 mm, but unfortunately we didn't get. But what we observed was the force was lagging to get into that depth. So what after that's what we think, like if we incorporate hydraulic system in this claw mechanism, we can really get a 70 mm and also some other depth we can incorporate some other crops. But so what we think is, if we incorporate these kinds of mechanism into the farm machinery, we can get a more revolutionary equipments more like this, and it will be efficiently used by the farmers. And hopefully, I'm very much hopeful that on the next presentation, I will be presenting hydraulic claw mechanism on the next upcoming conference. And the whole unit fabrication cost comes around 72,000. Thank you.
The session is open for discussion.
Why did you choose this particular, like for the minimum tillage for the maize? Like what was your rationale for that? Is it a very common crop here?
Not like that, ma'am. We are only concentrating on the mechanism, the innovative mechanism. That is what we are incorporating. For that, we just adapted that some random crop we get.
No, your research was on
The whole research is only based on that specific mechanism, ma'am.
and have you tried on other crops or did you?
No, ma'am. Actually, our research period was only last for 3 months due to the COVID. So in that time, we just did.
Okay, thank you.
It actually consumed 7 liters per hectare, sir. I have just in. Yes, sir. Sorry, 7 liters per hour. Thank you.
Thank you, Priyadarshini. Now I would like to call Devavatini Sarika.
Good afternoon, everyone. Myself, Devabatini Sharika, PhD scholar, Department of Food Science and Nutrition, Community Science College and Research Institute, Tamil Nadu Agriculture University, Madurai. So here now I'm going to present a part of my research work under the innovations in value addition. Topic is mathematical modeling of modified whey protein concentrate enriched nutri bar by using response surface methodology and artificial neural network. And coming to the research need, to reduce the organic load of the soil and to modify the whey protein concentrate by various processes and to enhance the functional properties of the whey protein concentrate and to introduce new protein based food ingredients in food systems by incorporating modified whey protein concentrate. So coming to the introduction, whey is a byproduct whey is a byproduct in the dairy industry. That is during the cheese production, that is during the curd extraction, we will get the water, that is the whey. It is a waste product during the cheese making process that is disposed into the environment. That is yearly 115 million tons of whey is produced worldwide and it is disposed into the environment. So it is a high organic pollutant. Whey is a high organic pollutant. It contains a high biological oxygen demand and chemical oxygen demand. So because of this high content of BOD and COD, it will endanger the structure of the soil when it is disposed into the environment and it will reduce the crop yields. So utilization of surplus whey is a challenging in the dairy industry. So we can use some of the valorization technologies to utilize the whey into some of the useful products. So here we can use the membrane filtration techniques for the production of whey protein concentrate and isolate. So here I have used whey protein concentration for my research. That is, it contains 80% of the protein. And coming to the reason why I have taken whey protein concentrate, because it contains all the 9 essential amino acids. And if it contains all the essential amino acids, it's called as a complete protein. And it is also have high biological value. And it have different functional properties like foaming capacity, gelling, emulsion capacity, and solubility. Although it contains functional properties, during the production of whey into whey protein concentrate, the functional properties will get reduced, that is unstable. So here I'm going for the modification process of proteins. Modification is nothing but changes in the changing of structure so that we can improve the functional properties. So coming to the objectives, these are my objectives, that is modifying the whey protein concentrate and nutritional composition and functional properties analysis of the modified whey protein concentrate and incorporation of modified whey protein concentrate for a development of the new food ingredients. And here, coming to the first objective, here I have used enzymatic modification of whey protein concentrate. This is one of the method for modifying the whey protein concentrate. Here I have used enzyme called trypsin. So here the whenever we are using trypsin, so it will hydrolyze the disulfide bonds. So it disulfide bonds to free sulfhydryl groups. So it will unfold the protein and it will improve the functional properties. So here, after adding the enzyme, I have freeze dried and grounded into the powder. This is a modified whey protein concentrate. And coming to the objective 2, this is the chemical composition and functional properties of the whey protein concentrate. The whey protein concentrate contains 76.4% of the protein and energy is about 388.4 kilocalories. And coming to the functional properties, so the non-modified and modified whey protein concentrate functional properties are compared. So here the functional properties are improved compared to non-modified one. So here I have analyzed the SEM analysis, that is scanning electron microscopy. So here we can see the non-modified one and modified one, the structural changes. So coming to the objective 3, so I have developed modified whey protein. I have developed a NutriBar by incorporating modified whey protein concentrate. So this is a composition. I have used whey protein concentrate from 10 to 20%, and I have used some of the millet flakes also for improving the micronutrient composition of the NutriBar. And this is the flowchart for the preparation of NutriBar. This is the product I have developed. And I have used response surface methodology for the optimization of protein concentration. So using design expect software. So here I have used independent variables, texturized whey protein concentrate, that is modified whey protein concentrate, millet flakes and brown sugar. I got 20 runs. And I have used dependent variables, protein, crude fiber, and the color values and overall acceptability. These are the important parameters to analyze an protein bar. So I got best treatment, that is a protein optimization. Fourth treatment got best results, that is it contains 22.29% of the protein and 1.13% of the crude fiber. So, and also I have used artificial neural network for comparing the best treatment to optimize the protein, that is using MATLAB software. So here the RSM, response surface methodology, got the best results compared to the artificial neural network. So coming to the chemical composition of the NutriBar, so it contains 22.29% of the protein and energy is about 399.402 kilocalories. So that is equal to 1 meal. And coming to the production yield and some of the physicochemical properties of the NutriBar. So here the production yield is about 98.99, and coming to the texture analysis, it is highly acceptable by the consumers. And coming to the conclusion, so the enzymatic modification process, it is affordable, and using this process, the functional properties are improved and it acts as a novel protein ingredient. And the consumption of one protein bar, which will provide for nearly 400 kilocalories, that is equal to 1 meal, and it provides protein about 25 to 30%. So that is it meets 25% of the daily protein requirement. And coming to the future recommendations, I have used enzymatic modification process for modifying the whey protein concentrate. Here we can use the other methods for modifying the whey protein concentrate and incorporate the modified whey protein concentrate. Incorporate the modified whey protein concentrate to develop some of the meat analog products using 3D printing technologies. And these are the references. Thank you.
How much would be the cost of the bar, protein bar?
Sir, 25 rupees, sir.
25 rupees.
25 rupees.
Have you done any validation or sensory evaluation for that?
Yes, sir. I have done sensory evaluation in my department.
Your department?
Yes, food science and nutrition department, using 25 semi-trained panel judges.
Not seen any photograph of the product
Yes, sir. I have included
included.
photograph of the product.
Your title is mathematical modeling. We cannot see any model. What do you mean by that mathematical modeling?
Sir, I have used the response surface methodology.
It's not a model. It's a software.
It's for software.
Okay. We thought of you model something and you develop some model.
Sir, yes, sir. Using mathematical model, sir. Response surface method.
Totally different. Mathematical modeling is totally different. So you have used some design software.
Yes, sir.
Okay. You use design expert, right?
Design expert and MATLAB, sir. I think 3 point, sir. Yes, sir. Yes, sir. It is for hydrolyzing the whey protein concentrate, sir. Yes, sir. Whey contains low pH, and we have to. I have used a trypsin enzyme for the hydrolysis of the. Sir, trypsin or chymotrypsin I have mentioned, sir, but I have used a trypsin, sir. Yes, sir. Up to 8 times. Sir, we can use the trypsin concentration up to 8.
Like maybe the starch, the fiber, and the proteins. So is it a balanced one? You have a proportion?
Yes, ma'am. It is balanced. It is providing 25% of daily requirement of protein, ma'am. Protein, and it is providing 1 meal calories by consuming of 1 protein bar.
Does it like the fiber content is from where?
Millet flakes, ma'am. I have incorporated millet flakes for micronutrient enrichment. Yes, yes.
Thank you.
Thank you.
Same only, sir. Combined experiment, pooled analysis only, sir. Yes, sir. Yes, sir. Thank you.
Next, I would like to call J. Gitanjali.
Greetings, one and all. My topic is performance evaluation of continuous pretreatment reactor to enhance the biofuel production from Carbon grace. Next slide. Uh, like biofuels is a fuel which is derived from renewable energy source. So here mostly from biomass we derive bioethanol for applications. Why we go for biofuels is because of fossil fuel which contributes like 1/5 of global CO2 emission. So this is the right time to go into explore a cheaper and environmental friendly fuel. So whereas the conventional sugar or cellulose based ethanol, which also reduce CO2 emissions by 65 percentage for sugar based ethanol and 75 percentage for cellulose based ethanol. The problem is these sugar based or cellulose based ethanol or edible one. So we have to explore into new one. So here we what we did is we explored crop called Campanapier grass, which is a perennial crop and which have more yield. So ethanol blending in India, it is about like 9.45 percentage in 2022, and it's expected to reach about 20 percentage in 2025. It was given by the Ministry of Petroleum and Natural Gas. So the conventional ethanol production is like 30 to 50 percentage. When we go for like novel or theoretical based, they say it is like 90 to 95 percentage. Among that, like we have done a research called continuous reactor where we can reduce the cost of pre-treatment and in order to enhance the efficiency of ethanol production. And so for going to a pre-treatment method, we have to first see what is the biomass composition. Here we have taken Campanapier, which eats around 360 to 400 tons per hectare per year. That's an TNAU variety, and it's a quick regeneration capacity. And it has a lignin like 14 percentage, cellulose 31, and hemicellulose 20.3 percentage. And when we go to pre-treatment method, there are several methods and several researches have been done. And it's like physical, chemical, biological, and combined. Here, what we choose is it's like from size reduction, that's mechanical based, and the next is chemical, that is acid based, and we go into steam explosion. All these are continuous based process. And for Campanapier grass, we have like cell wall and microfibril, which is the like lignocellulose. It's binded with lignin. So our material for ethanol production is cellulose. So cellulose has to be taken by the enzyme so that ethanol has to be produced. So for that, we have to break this lignin. So for that, when you go for acid treatment, we can see the breakage between lignin, hemicellulose, and uh, cellulose content, whereas when we combine with the steam explosion, there are the breakage is more. So we choose acid treatment along with the steam explosion method. Next. The flow chart. So biomass, it is Campanapier has been taken, and then it is size reduced to particle size like 5 mm after dried, and then it has been treated with orthophosphoric acid. Why orthophosphoric acid? It is not carcinogenic one, and it's a popular method of acid treatment. And then it is steam exploded, and then we have a solid liquid separator where it separates both solid substance and liquid substance after the pre-treatment, and this is solid substrate can be used for ethanol production. So lignin reduction in the laboratory scale experiment by varying the acid percentage like 5 to 10 percentage, and then reaction time of acid like from starts from 30 minutes to 3 hours, and then pressure like 1 to 2 bar of steam, and with residence time of 5 to 15. And we found that lignin has been reducing in all the stages, and even when you go for 2 bar, it has been reduction is more. But when you consider about the electricity and all those stuffs, and it is well significant if you stop with 1.5 kg bar and 1 kg per centimeter square of pressure explosion to the Campanapier grass. And this is a pre-treatment reactor developed, and this is a continuous one. So in hopper, we feed the biomass, and it is fed into the through conveyor where there is a steam explode arrangement. the reaction between the contact area has been increased so that our common aper has been treated well and lignin has been destructed and it is collected in the soil solid liquid separator where you can separate like it is in a drum like system setup and centrifugal force because of centrifugal force dry matter and the liquid has been collected separately and this can be directly fed into a ethanol reactor, its fermentation. And in order to validate the results, it has been analyzed in RSM software design expert. Company pure grass of less than 5 particle size, one factor is taken. And then with the varying acid concentration, 0 to 10%, total solid ratio like 5 to 20%, residence time 30 to 180 minutes for acid treatment alone. And then for steam pressure, 0.5 to 2 bar and steam explosion time, that's 10, 20 and 30 minutes in order to validate. Among that, we found that lignin loss is more and the next one is cellulose rise. So since available cellulose, we have not increased the cellulose content in the company APR, but the availability of cellulose has been increased. And after the optimized result, we analyzed for the same results. It's raw sample. So raw sample, you can see that it's in a rigid structure and structured in a line manner. And when we treat with acid treated sample, we can see the structure has been broken. And with the acid and steam explosion, it has been shows that the porosity has been increased so that the effective area for the microbes to act upon that surface area has been increased. And XRD results again confirms that the crystallinity index raises from 28 to 48. Again, this also shows that higher digestibility possibility for enhancing our ethanol production. And summary conclusion, and from this pre-treatment reactor, we found that cellulose rise has been like 10 to 12, like 10 to 12%, and lignin loss is from 9 to 13%, and optimized condition is like soaking 10% TS content for 1 hour, and phosphoric acid less than 5%, and even if you increase the 5% also, the loss is very the result is very less increase. So we stopped with 5%, and steam explosion time 10 minutes, and pressure is 1.5 bar. And if you increase the bar also, the yield of the cellulose rise only by 2 to 3% overall the ethanol production and all. So we stopped with this. This is the optimized condition, and the total working cost of the system is like 1.5 lakhs for 5 kg per hour, and the cost operation cost is around like for 1 kg of biomass, it comes under less than 1 rupees. So it's well suitable for ethanol production. Thank you. Yes, sir. Cost of treatment, it's along with the steam rate and the phosphoric acid rate, not with the manpower, only with the cost of energy. Sir, 10% solid loadings. Yes, sir. Total reductions. So, so like initially it was like 40 to 50% in laboratory conditions, sir, and after that I'm not sure about this 9 to 13%. Yes, sir. Like from 14%, it has been might be. I'm not sure. I'm like, we stopped with the pre-treatment setup alone, ma'am. We didn't like it is an ongoing project, and we didn't go for ethanol production. And the thing is, like both the ethanols, whatever may be from sugar-based or cellulosic based, ethanol concentrations or ethanol quality will be the same. Just we are replacing the feedstock. So the way they have like hindrance is lignin. So we our area is uh, uh, to solve the problem of lignin hindrance. So we have to destruct the lignin binding. Yes, ma'am. Because carbon napier is like nowadays they say it grows very fast, and most of the countries also they prefer carbon napier grass for the availability. They prefer cultivation carbon napier. Thank you. Sir.
What is the material of the reactor?
Steel, sir. It's maybe like 29 trials, sir. 29 to 30, 35 trials. And we didn't see any erode erosion. Maybe if we open the screw conveyor, we can see, but on outside, we haven't seen anything. Interior, we haven't seen, sir. Maybe we can open it. Yes, sir. We'll check it. Thank you, sir.
Next participant is S. Santosh Kumar.
So good evening, everyone. Myself is Santosh Kumar from Department of Agriculture and Microbiology. I'm here to discuss my part of the research on process optimization of enzol pretreatment in cotton waste using response surface methodology. So in this rapid industrialization era, the need for fuel is very much increasing. So it is estimated that the population of the world will go high by 8.5 billion by 2030 and 9.7 billion by 2050. So why lignocellulose? It is readily available and carbon neutral, and it is inedible bioresource which is usually wasted in the field, especially in agro residues, or mulched directly to the field or burnt. So it is completely a waste to the farming community. So why agro residues? It contains high energy content, the presence of highly reactive groups. This lignin offers a specific opportunity for derived chemicals, that is biomass derived chemicals from the waste agro residues. So based on the data available from Cotton Association of India, India ranks first in the world in cotton production, which is directly proportional to cotton waste production. India ranks first in cotton waste production also. So it is estimated that 387.89 lakh bales of cotton is produced annually. That is, one bale is 170 kgs, and the waste market, it was rapidly increasing. It is estimated to increase in the past 10 years for almost double. So let us assume a calculation for a cotton of spacing 60 by 60 centimeter, and for a 1 hectare of land, there are about 25,000 of plants approximately. For each cotton stalk varies approximately 100 grams, and if it is milled and reduced to particle size based upon the utilization, 50% of the weight gets reduced. So from 1 hectare of land, we can able to get 1.3 tons of milled cotton stalk powder, so which can be used in this process. And the total cultivable area of cotton in India alone is 120.69 lakh hectares. So upon calculating theoretically, the amount of biomass available in India alone is 167.625 lakhs of metric tons. So we are full of resources, but lack of technology to process the waste and retrieve the value-added chemicals from it. So this is the cotton spinning process. I have chosen cotton waste, that is cotton stalk, cotton spinning waste, and cotton ginning waste. So this is the overall schematic of cotton spinning process. The end waste, neon fill and hard waste, it was again recycled back into the spinning process, or is utilized for low value yarn production. So the top 5 waste, blowroom droppings, liquorine flies, flat strips, compound oils, and micro dust are selected for this process, along with the ginning waste and cotton stock. So this is the enzol pre-treatment process, which was patented and developed in our laboratory. So initially the waste was steam treated with at 121 degrees Celsius for 1 hour. The steam treated biomass, it was processed in a bioreactor along with the 2% of solvent and enzyme. Enzyme used here is a lacase derived from Hexagonia hirta. It is a basidiomycete fungi. So the once the pre-treatment process was over, it was 17 hours of incubation and it was 35 degrees of temperature. So the biomass, delignified biomass was retrieved, and hydrolysate was also retrieved. So I am focusing on hydrolysate, which has lignin derived aromatic compounds that has a high value in market. So optimization. So we have to optimize this process for cotton. So I have selected the most intrinsic parameters, that is moisture content of the biomass during the steam treatment, enzyme load, incubation time, incubation temperature, and shaking speed. So these are the 5 intrinsic parameters I have chosen for optimization. So the raw biomass and conventionally pretreated biomass, it was subjected to composition analysis. The blue ones are lignin and the yellow ones are cellulose. In the left side, it was for raw biomass, and the conventionally pretreated biomass on the right side. So the lignin content was reduced and cellulose content, it was increased for all the biomass. Next one. So upon optimization, it is pre-optimization, the 5 intrinsic parameters that are optimized for and the lignin content was estimated. So the moisture content, it was 0%, 4%, and 100% for the 7 biomass chosen. And the enzyme load, it was constant for all the biomass, that is 50 units per gram of biomass. And the incubation time, it varies from 5 hours, 10 hours, and 15 hours for the biomass chosen. And the incubation temperature is 40, 45, and 50 degrees Celsius. And the shaking speed is 80 RPM, 100 RPM, 150, and 180 RPM for the 7 different biomass chosen. So based upon the pre-optimization studies, statistical optimization was carried out under a box-Benken design. So the lignin reduction was compared based on the pre-optimization and statistically optimized data. So it was 68.66% of lignin, it got reduced. The raw biomass contains about 26% of lignin, and 68% of it was reduced in the Enzol pre-treatment process. Upon statistical optimization, it showed 75%, 83% of lignin can be reduced following the optimized parameters. So from the hydrolysate, the corresponding during the process of optimization, the corresponding sugars were also analyzed. So initially raw biomass, it was digested, and the carbohydrates was estimated. It was 204.9 microgram per ml in cotton stock alone. So upon optimization, the final sugar value was 6,265.5 microgram per ml. So the optimized process, it showed 30-fold increase in sugar content in the hydrolysate itself. So what is the future thrust of this research? So after pretreatment, we are retrieving the pretreated biomass as well as the hydrolysate. The pretreated biomass, it can be subjected to saccharification, further ethanol production. But the major focus is on lignin-derived aromatic compounds, which contains the phenols, vanillin, eugenols, atrazine, hydroxybenzaldehyde, those compounds which are for high value in cosmetics, pharmaceuticals, and green chemical production industries. So, next one. So to conclude, so this biomass cotton stock, especially cotton stock, it was proved to be efficient biomass for lignin valorization to obtain lignin-derived aromatic compounds. So this shows the inputs of low value to convert it into high value, thereby proving the zero waste and the circular economy concept. So these are the products which we are aiming in the future for bioethanol produced from the saccharified biomass, xylene extraction, which was under the pipeline, and xylo oligosaccharide production from the xylene extractor. So recently, the part of the work got published in Bioresource Technology. Finally, I would like to conclude that by saying that waste is not wasted until it is wasted. Thank you. No, ma'am, because still we are in laboratory scale production, ma'am. Once we enter into pilot scale production, we will try to work on the economics also, ma'am. So far, we are focusing on mass balance ratios alone, ma'am. So with that, we can work out the economics also, ma'am. Sir? So no, sir. No, sir. Sir, but so far only the solvent cost was higher, sir. Actually, I calculated theoretically, but based upon the product we extract from this process, If it is high value compound, we can meet up with the cost of the solvent also, sir. We are using 2% ethanol as a solvent. 500 ml it costs around 1,000 rupees. So if we get a vanillin as a product and if we extract and we develop the process for purification, so the value of vanillin is high in this markets. Sir, so far we just non-targeted. It was yes, sir. It is 0.3% non-targeted identification, sir. But upon chromatographic purification, we can retrieve more also, sir.
Thank you.
Thank you.
Last participant for the oral presentation is M. Aruna.
So good evening to everyone. My topic, I'm self my Aruna, Department of Food Science and Nutrition. So my topic is studies on physical chemical for preparation of functional paneer. So this is one of the my small part of research work. Next slide. So first of coming to the A2 milk. So basically milk is classified two types. One is A1 and A2 milk. So the different types of A1 and A2 classified based on the amino acids. So in A1 type of milk at the 6th position, the proline is presented, whereas in A2 type of milk, histidine is presented. So this is the major reason for the A1 and A2 type of milk. So in this A1 type of milk, the BCM7, that is the beta casomorphin 7, that can be only produced for the major reason. So that BCM7 is production is based on the pH dependent. The ideal pH is 4. So whereas in A2 type of milk, the BCM7 is not produced. So when we consume that A1 type of milk, that can lead to the several disease like lactose intolerance, diabetes, sudden infant death syndrome. So A1 is the crossbreed like Jersey. So A2 is the Indian breed. So it is like Puliculam breed and Gongayam. So I have chosen for research work is the Puliculam breed that is originated in the Sivagangai district. So coming to my research work, so the major causes of is the lactose intolerance is nothing but the inability of production of insulins for to break down the sugars from the milks. So in world population, 70% of the adults have low production of the lactose enzymes. So in day-to-day life, we are consuming A1 type of milk. So that milk has contained more amount of calcium, vitamin A and D. So these vitamin A and D for prevent the uh, prevent the bone formation and atherosclerosis. So from this atherosclerosis, we can exclude it from the diet. So for this reason, we can consume the alternative for the A1 milk. Another one is diabetic meltus. So diabetic meltus can be classified two types. One is type 1 and type 2. So type 1 is basically occurred in the elderly people and type 2 is occurring in the children. So in children, the diabetes can occur only in the birth. In type 1, it can occur in the elderly. But in this type of, the insulin is not produced the enough amount. So next we coming to the A2 type of benefits. So A2 milk is a more polyunsaturated fatty acid when compared to the A1 milk. Next slide. So the A2 milk has contained a high amount of antioxidant and also it reduces the serum cholesterol level and it also is a treatment to the cancer and it increases the immune booster system. So due to this high nutritional content of the A2 milk, we can choose for alternative for the athletes person for pre and post workout. So this A2 type of milk based meals for the requirement for the dietitian by the athlete people. So nowadays, the A2 type of milk can be increased due to the low fat and high in protein content. So these like this is diabetes, lactose intolerance, sudden infant death syndrome, cardiac disease. It can prevented by the consumption of A2 type of milk. And another one is encapsulation technique. So I have chosen for the research is mint. So mint is used for the medicine, and also it acts as the anti-inflammatory, anti-nuclear and anti-tuberculosis and antimicrobial activity. Next slide, sir. So in my research work, the main objective is to quality assessment of development of value-added polygram breed. And next objective is to standardize the methods of encapsulation technique. So encapsulation technique is a process that acts as the carrier material So when we using the encapsulation technique for making product, we are using different type of processing methods. So without encapsulation technique, we use different processing methods. There is a change in nutritional components. So this change in nutritional components can be maintained by the use of the encapsulation technique. And I have used the bioactive principles from mint. So mint has contained the high amount of bioactive compound is menthol, and turmeric has contained the curcumin active compound, and moringa is the quercetin. So in my research work, I have one topic of the mint and another topic is study process optimization. So from the bioactive principle, I have developed the A2 type of milk and milk-based dairy products, and finally I have developed the functional variant products from the nutritional components. So this is the process of encapsulation technique. First, I have taken the mint leaf and I have the cabinet drying for 60 centigrade for 1 hour. After that drying, we can make the fine powder for by using the pulverizer. So after that, we can extraction by adding the maltodextrin. So maltodextrin acts as a carrier material. So after that, we have spray drying in the temperature is 60 centigrade and outlet is 190. So the flow feeding rate is 1200 RPM. By using the spray drying, we can make the encapsulated mint powder. Next slide. Next slide. So this is a composition. So I have chosen 4 different concentrations. So 0% is a control, 0.25% and 0.75% and 1%. So this is the process of encapsulated paneer. Next slide. So this is I have developed the incorporated mint based paneer. T0 is the control, that is mainly in the A2 base of milk, meat based paneer. So T1 is the 0.25% encapsulated milk extracted paneer. So these are the physical chemical analysis of the encapsulated spray drying paneer. So when compared to the A1 type of encapsulated spray drying paneer, so the A2 milk based paneer has contained the highest amount of carbohydrate 2.98% and the moisture content is 3.33% and its encapsulation efficiency is high in the 91.34% when compared to the A1 type of milk based product. Explain. So another one is proximate composition of encapsulation based paneer. So the major is I have developed 4 different concentrations. From these 4 different concentrations, the 0.24% has contained the highest amount of carbohydrate to 27.01% and ash is 2.62% and the pH is 5.89%. Next slide. So this is the morphological structure of encapsulated mint powder. So when compared to the other A1 type of encapsulated mint powder, it has the highest molecular structure. Next slide. So from this research work, I have conclusion. I have chosen 4 different concentrations by using the A2 type of milk-based paneer. So in this different concentration, the T1 there is a 0.24% that has the highest amount consumer. It has enriched the nutritional value and it has increased the nutritional composition by the consumers. Thank you. Yes, ma'am. Yes, ma'am. It contain the questioning is the bioactive principles, ma'am. It is easily available in all over, ma'am. This act as superfood, ma'am. It can be easily in any place available, ma'am. Yes, ma'am. My next topic is both 3, ma'am. Mint, turmeric, and the moringa, ma'am. So in this, I have done only the mint included, ma'am. By mistake, ma'am. Sir. Sir, by increase the nutritional values, sir, and it also easily consumer by the consumer, sir. Sir. Yes, sir. Because it has contained the highest amount of antioxidant and anti-nutritional values, sir. Sir. Sir, I also done the moringa, sir, but in this slice I had only include the mint, sir. 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 Yes, sir, in my department I have done, sir. Sir.
don't know, you have people have to take favor from you.
Sir? Yes, sir. Thank you. Sir.
As a token of appreciation, I request the organizers to present memento to the evaluation committee members. I request our beloved Dean Sir to present memento to the chairperson, Dr. Bala Shankari ma'am. I request faculty reporter and student rapporteur to present memento to Dean Sir. Now I request Dr. Bala Shankari ma'am and Dean Sir to present memento to the evaluation committee members, Dr. S. Kartikeyan Sir, Dr. M. Balakrishnan Sir, Dr. R. Kavita ma'am. I request Dr. Bala Shankari ma'am and Dean Sir to present memento to faculty rapporteur. As we come to an end of this session, now I invite Engineer Rahuri Sai Prashant, rapporteur student, to give vote of thanks for the session.
Esteemed guests, speakers, and participants, a joyful evening to all. On behalf of Students Committee of 8th AGSC Conference TNIU, I stand before you with heart full of gratitude and appreciation as we draw the curtains on this remarkable oral session on Theme 4, Innovations in Bioengineering and Value Addition. First and foremost, I extend my heartfelt thanks to our Honorable Vice Chancellor Ma'am for permitting to organize this kind of conferences by the students community. Next, I extend my wholehearted thanks to the chair and convener of this conference, Dr. N. Sendil sir, and his organizing team for providing all the facilities and conducting the event in a well manner. It's my honor to thank the chairperson of the session, Dr. Bala Shankari Krishnan ma'am. Really, your presence in this session as a chairperson is a privilege to all the participants. And the ideas you shared with us, really thought-provoking, ma'am. Thank you. I extend my warm thanks to co-chairman of the session, our beloved Dean Engineering, Dr. A. Raviraj sir. Your contributions in the arrangements for the conference and your support was really noteworthy, sir. Thank you, sir. I would like to thank all the evaluation members, Dr. S. Kartikeyan sir, Dr. M. Balakrishnan sir, and Dr. R. Kavita ma'am for your keen observance and insightful discussions with the participants to enhance the research ideas and evaluating the topics of different presenters. Thank you, ma'am, and thank you, sirs. And I would like to express my heartfelt thanks to all the participants for your patience listening. I would like to extend my thanks to organizing team, volunteers, behind the scenes staff who have worked tirelessly to ensure the smooth functioning of this event. Further, a big thank you goes to Professor and Head Department of Entomology and helping staff for providing us with an experiential environment, the facilitating learning, networking, and for allowing us to conduct this event. In closing, I would like to say that it's not just the end of the session, but the beginning of a new chapter in our research journeys. Thank you all for being a part of this scientific knowledge sharing event and here to future with innovation, progress, and positive change. Thank you, one and all.